Hi friends, my name is Nilesh. In the previous video, we had seen how to use Kubernetes rolling update strategy to perform a Kubernetes deployment with zero downtime. In that, I had talked about the alternative to the rolling update strategy, which is recreate strategy. So I thought, why not cover that as part of this video? So this video is all about how we can use the recreate strategy with Kubernetes deployments. So let's get started. First, let's go and see what is the state of our Kubernetes cluster. I will run this command to say kubectl get deploy to see which deployments are currently available on my Kubernetes cluster or which deployments have been performed. Currently in the default namespace, there are no deployments performed on this Kubernetes cluster that I'm using. This is the Azure Kubernetes service or AKS cluster that I'm using for demonstration. So let's look at the producer deployment that we used last time for the rolling update strategy and see how we can use it to make use of recreate strategy instead of the rolling update. So I'll use the same producer deployment YAML file which starts with the API version deployment and the metadata related to this deployment. As we saw in the last video, we used 20 replicas of this particular producer deployment. So we had 20 instances of the RabbitMQ producer running in our cluster. We are going to use same number of replicas this time as well. And the strategy that we will use is recreate. What this means is all those 20 replicas that we have in our Kubernetes cluster, they will be recreated in one shot. We will not see a progressive upgrade of the version, and all the instances will be replaced in one single go. So let's go and deploy this. I will start with the version which is RabbitMQ KDA 5.0 as the first initial deployment. Let's go and apply this particular Kubernetes deployment. So I have the producer deployment.yaml, that's the file name. Let's run this kubectl apply command and apply the producer deployment YAML file. So we see that the deployment has been created. Let's go and create a watcher here on the deploy. So we want to keep a watch on what is happening with our deployments, and on the left hand side let's go and keep a watch on our pods. So here we see that about 18 seconds ago, 20 pods of the RabbitMQ producer deployment has been created, and the deployment itself with 20 replicas has been created about 8 seconds ago. And all of those 20 replicas are currently available. Now let's see what happens when we upgrade the version of this particular deployment, or when we want to produce or deploy a new version of this particular deployment. So for that, I'm going to change the tag of my container image. I will change it from RabbitMQ KDA 5.0 to RabbitMQ KDA 6.0, which is the next version of this particular application. Now let's go and apply this new manifest file and see what happens. Let's switch to the watchers, and we can see that all the watchers are, all the pods are getting terminated. And on the right hand side, if we see the deployment, it was up to date for 20, and when we ran the update command or apply command for the new 6.0 version, all of those 20, they became unavailable. So at one point in time, we had 0 of the 20 replicas up to date and 0 of them available. If we look back at the earlier video, we saw that progressively whatever was the percentage we had given for rolling updates, it was applying the progressive change. Whereas here, all the pods are taken out and all of them are replaced in one single go. That is the difference between a rolling update and the recreate strategy in Kubernetes deployment. So like I showed you last time, let me show you the same thing using another way, where let's say I want to roll this back from 6.0 version of my image tag. I want to roll back to the 5.0, which is the earlier version, and we will use Lens this time. Lens is the visualizer for my Kubernetes cluster. It's an open source tool which we can use. So here under the workloads, under deployments, we can see the RabbitMQ producer deployment currently has 20 pods with 20 replicas for the deployment, and all of them are available. So let's go and revert back the change and see the same change, how it looks like in the Lens UI. So here again we can see that the moment we apply the rollback feature, which is reverting back the tag to the 5.0, all the 20 pods have been removed and they are now upgraded. So that is the difference between a rolling update and the recreate strategy. Now the question might be, when do we want to use rolling update and when we want to use recreate strategy? Rolling update is used when we don't want to have a downtime for our application. We want to progressively change the number of replicas from the older version to the new one while keeping the application running. Whereas recreate is used when it is okay to have a slight downtime. When it comes to Kubernetes deployment, we saw that it doesn't take a huge amount of time. But since all the 20 replicas of the application are going to be recreated, there would be a slight downtime here when that switch happens between the old and the new version. So typically if there is a in-house application which is used, let's say, sparingly, and it's okay to have a small amount of downtime, in that case we can use the recreate strategy instead of the default rolling update. Another scenario where we might want to force the recreate is when there is a breaking change in the application and we don't want to have the old and the new version running at the same time. We want to make sure that the most updated or whichever version we want is the one which is running, and for that reason, if the old version has to be taken out, in that case we can use the recreate strategy. So with that, we come to the end of this video. I hope you found it useful. In case you find these videos useful, please hit the like button, subscribe to the channel. That is what is helping me to create these kind of videos, and please feel free to put the comments and feedback if you have. Thanks for watching this video.